Hello, grade 10s. In this video, we are going to be looking at the answers for the exercises you had to do on chemical formulas and balancing of equations. So I need you to go to page 7 of your booklets. I already gave you the two examples of copper nitrates and zinc carbonates. And now I want you to look at the answers and mark your own work. Check that you are getting everything right. And I'll read a few of them. I'll go through a few of them with you. But once again, if you are stuck, if you are still struggling with polyatomic ions or charges, as well as the stock notation, please drop myself or Mr. Ginsberg a message and we will organize a private video call. So just have a look at a few of the answers there. For example, magnesium sulfite. So that's the Te. That means that it has one less oxygen than a sulfate. And therefore, I'm going to just have magnesium SO3. You don't need to add any extra atoms or any extra charges. Sulfur oxide, when you read it, you do not need to read the full Roman numeral. You can if you want, but it's also not the end of the world. And in this situation, we've got a charge. The sulfur has got a charge of 6+. Therefore, I need 3 oxygens to balance it out. Then you have aluminum phosphate. Pretty straightforward. The charge is balanced. Barium bromide, which I need 2 bromides. Ammonium sulfate. Here I'm going to need my ammonium, 2 ammonium cations, which have been put in brackets to balance out the sulfate anion. Then we have sodium dichromate. Here we've got 2 sodiums for the dichromate. So always, when you get stuck, have a look at your polyatomic ions on page 2 and just make sure that they balance out here. Potassium chlorate is stable. Nickel 2 sulfide. The nickel has got a charge of 2+, sulfide's got a 2-. So it's just going to be NiS. Iron chloride, iron 3 chloride, which means that I'm going to need 3 chlorines to balance out that particular iron atom. Then we have nitrogen oxide, which is going to be N2O. And I know what you're thinking. Nitrogen is not a transition metal. Why are we using the stock notation? The stock notation can be used for other compounds as well that with differing charge. This is just the beginning, grade 10s. There's much more to learn. Then we have lithium ethernate. Now I know what you're thinking. Why is the Li at the bottom or at the back? It's all got to do on how the molecule bonds, how that polyatomic ion is bonded to the lithium. This is an exception. So this would be an extension question, and we would not ask this of you unless we gave you additional information first. So don't stress about this one. Then we have silver 1 hydroxide, and in this situation, it's just perfectly balanced, no problem whatsoever. So please pause this slide if you haven't checked your answers yet, and then we'll carry on to the chemical equations portion of the video. I'm not going to spend too much time on this because I think a lot of it is pretty straightforward and easy. I don't think it's difficult at all. I want you to just be mindful of your coefficients. So you can see, we have magnesium chloride. There's no additional coefficients. However, for the ammonia, there's going to be a 2 there. So there's 2 molecules of ammonia because remember that hydrogen there, that hydrogen, I had to add 3 over there. So to balance it out, I need to put 2 in front of the ammonia. Lithium oxide and water, you're going to have 2 lithium oxide molecules, okay, because of how lithium oxide has been written, the chemical formula for lithium oxide, and your 2 hydrogen atoms, you have to have 2 that's put in front over here. Carrying on with the chemical equations, which are on page 4 of your booklets. Once again, just check. We're going to go through them super quickly. I don't think I need to procrastinate on this. I think it's pretty straightforward. And if you're getting these right now, then that's a good sign that when we carry on, when we start with the mole and we start with empirical formula, that you're going to see how these coefficients link to your mole and your empirical formula. So I'm just highlighting everywhere that you need to double check. Okay. And you can see it actually makes quite a lot of sense. So if I were you, I'd write out the formulas of the tricky reactants. The reactants that you're not too sure about, I want you guys to write them out. So when you get that iron 3 oxide, write it out first, and then you'll see, okay, I need to add a coefficient here, I need to add a coefficient there. G over here is a little bit tricky with the copper nitrate. You need 2 nitrate ions to balance out that copper. And then because of that, the copper 2 oxide and the nitrogen oxide is going to be different. That coefficient is going to be 4 and that's going to be 2. Then for H, you're just going to add 2 molecules of nitric acid. Remember the H is silent. And for the I equation, you will see we've got a different chemical formula there that you might not have ever seen before. And you're probably like freaking out a little bit. But guys, that's carbon dioxide. Okay, that's carbon dioxide. So we threw that in there to throw you a little bit off. So it's literally just CO2. That's all. To balance, so that we need 2 oxygens to balance out that carbon. Okay, so once again, just pause this video and then we will carry on to the next slide, which is going to have J and K on it. The last 2 chemical equations that you need to double check is your sulfur oxide and oxygen, and your magnesium and steam. Guys, what is steam? Steam is water. Steam is water. So it's going to be H2O. So double check this. I think by the time you have marked all of this, most of you will probably feel pretty confident. I don't foresee any problems here. I think this is pretty straightforward. There isn't anything that is completely unfair or out of the ordinary. So in the next section, we're going to go through a few more practice, a little bit more practice on page 5, and then we're going to look at the equations with the phases. So on page 5, like I said before, these are the answers for those 5 chemical equations there. These are a little bit more tricky than the ones from before, especially with those polyatomic ions. Bear those polyatomic ions in mind, guys, because if I need 2 nitrates, for example, that's going to influence everything else before the equation or even after. Or if I need 2 hydraulic acids, that is going to influence how I'm going to write my magnesium chloride. Here we've got cobalt iodide and calcium sulfate. And if you look carefully, what's happening there? That is a double displacement reaction. You've got iron oxide and lead fluoride leading to lead oxide and iron fluoride. Okay, once again, exchange reaction. And aluminum bromide and potassium, okay, we need to put a 3 in front of that potassium because you're getting potassium bromide. And we know that we needed 3 atoms of bromine. okay, to cancel out the charge of the aluminum cation. So make sure that you write, my advice to you guys is write out your formulas first correctly. Make sure that the charges have been neutralized. Okay, make sure that the formula is correct first, and then start adding coefficients. On page 5 of your booklets, you will see that there are 14 descriptions that you needed to look at, and then you needed to write out your chemical equations based on those descriptions. Sometimes we gave you hints and we told you exactly what was happening there. If we used the word metal, the chances are it's a solid. If we used any sort of terminology when it comes to decomposers, if you see the word decomposers, then 9 times out of 10 that is from a solid to a liquid or a liquid to a gas. So have a look at the answers that we have in front of you right now. Double check your phases. The phases are very important, guys, very, very important. And make sure that you have put in your abbreviations for solid, liquid, gas, and aqueous. This is the last slide of this very quick video. And here we've got the equations from question 8 to 14, the rest of that page. You should have these all written beautifully, neatly on page 6. And you will see that we even added the heat sign for question 11. And technically that triangle should be above the arrow, but it's okay if it's underneath as well. And I want you guys to, once again, double check everything. Once you have done this and you have checked your equations and you are happy and confident, I want you to attempt page 7 in the rest of the lesson. You need to take a picture of that page. Make sure everything is clear. Take a nice photograph. Don't take it at a weird angle. Otherwise, how am I supposed to see? And I want you to send that photo to a Teams chat, and then just so that I can see that you've done it. And then we will either give you back the answers straight away, or we will post the answers onto the general Teams channel. I really hope you guys are understanding this. I hope this is making sense. Just like last year when we did chemistry, the balancing is tricky. It's more of an art than anything else. You need to look at it as a process of elimination. And sometimes you're not going to get it right straight away. But if you if your formulas have been written correctly, then the balancing should be relatively easy and effortless. And the last thing you do after you've written your coefficients is always put in your phases. Okay, so I hope you're all great, and I hope you're all happy with this, and we will be chatting soon.